Cool. So as I said, today we're going to be going through kind of an intro to Airflow for beginners. I'm going to start with some slides just to introduce some of the core concepts that are useful to know when you're working with Airflow, kind of set the stage, get some of the vocabulary out there. From there, I'll move into kind of some helpful resources for those who are new to work with Airflow, just so you kind of know what's out there, know where to go for help. I'll go through a demo and kind of talk about what the Airflow UI looks like and how to go about building your first DAG. And then, as promised, in our key takeaways, we will also cover some sort of best practices for beginners. So as you're getting started, things to keep in mind that are going to make your Airflow journey a bit easier. So with that, I'll dive in. Airflow is pretty common and popular out there, so I assume most people have at least heard of it before. But just to give a very basic overview, Airflow is a tool for programmatically authoring, scheduling, monitoring your data pipelines. It was originally created inside of Airbnb. It's obviously since been open source. It's now a top-level Apache Software Foundation project. And obviously at Astronomer, we're heavily invested in open source Airflow. So we love that, it's super extensible, it's scalable, it has a massive, really vibrant community. We'll talk about what all of that means in practice and throughout this webinar. But we're super excited about where the project is at now and where it's going, and we think you will be too. So just to kind of touch a little bit on Airflow's core principles, sort of what it's built on. One of the main things that you will probably have seen if you've dove in a little bit materials is that everything in Airflow is written in Python. So that's one of the core kind of tenets of Airflow is pipelines as code. Anything you can do in Python, you can do in Airflow because of that, which is kind of what makes it super flexible, extensible. On top of that, there's the entire Airflow ecosystem designed to allow Airflow to play with other tools. So we'll touch on that as well. Obviously, it's open source. So, it's available for everybody. The project is super active and vibrant. There's a really large community. If you, want to contribute, you're welcome to do so. And, the Airflow project management committee, PMC, and committers love, having people contribute, as they see things that they'd like added to the project. So again, super exciting where it's at. Airflow has had lots of new, major and minor releases. Especially in the past year, there's been huge jumps forward in kind of what the project can do. So it's a really exciting time to get into Airflow. It's super, super widely used. The number of downloads per month is pretty astonishing. It's measured in the millions at this point, which I still have trouble wrapping my head around. But we think that that's only going to grow over time. So it's a really great tool to learn. And it's good in a lot of different use cases. So with that, kind of diving in a little bit deeper, want to cover again some of the core concepts that go along with Airflow. And I'm going to start by actually talking about the core components. So these are the pieces of Airflow infrastructure that you need to run in order to use Airflow. We won't talk too much in depth about these. These are more relevant for if you're like an Airflow admin. It's a little bit more on the DevOps side. Again, this is your infrastructure. Hopefully, if you're more on the DAG authoring side, you won't need to interact with these too much. But again, they are required to use Airflow. So even if you're just running it locally, you have to have these things. We'll talk about how to set that up locally, but it's good to know what they are. And so Airflow has three main components that are needed to run. Those are the first three things shown here: the web server, the scheduler, and the metastore. The web server is so your Flask server uses Unicorn. That's going to serve your UI. So we'll talk through that. Your scheduler, obviously super important. That's the daemon that actually schedules your jobs. And then you have your metastore, which is a metadata database where all of your metadata is stored. Typically that's Postgres. It can also be MySQL or a few other things. You'll notice I have three more components here. These are not necessarily, I would even say, components of Airflow, but they are other pieces that are sort of intertwined with the infrastructure that, again, you'll likely need to know what they are sort of through your Airflow journey. The first is your executor. So this defines how tasks get executed. There are a couple of different options. I won't go too much into that today, but just note that, if you were going to run Airflow in production, your choice of executor can be pretty important depending on your jobs. And you do have different options there. With that, you also have workers, potentially, depending on which executor you choose. So those are the processes that are actually going to execute your tasks. So again, kind of depending on how you set up a potentially important piece of your Airflow infrastructure. And then finally, you may have what's called a trigger. So again, this is sort of more in the weeds than I would even consider for beginner Airflows, but beginner Airflow users, but just to note that it's out there. With newer versions of Airflow, you can use what's called deferrable operators, and that requires an extra process to run for them. So if you're out there kind of reading documentation or things in the wild and you see a trigger mentioned, just know that that's optional. It's for sort of a specific feature in Airflow. If you're not using that specific feature, you don't have to worry about it. Okay, so now kind of switching gears and talking more about Airflow concepts. So these are going to be more relevant for, again, DAG authors when you're actually interacting with Airflow. These are the concepts you're going to encounter. And the most high level concept within Airflow is your DAG. So that stands for Directed Acyclic Graph. A DAG is just your data pipeline. It's a different name. The only rules when you define your DAG are that your tasks flow in one direction and have no loops, so directed acyclic. With that, you can think of the graph part as each node in that graph is a task. Each edge in that graph is a dependency, kind of like this example on the left. Again, with the rules where you can't have any loops, this example on the right is something that would be invalid because of this loop between T1 and T4. Things like that can cause infinite loops in your code, obviously bad. So you can't do something like that, but otherwise Airflow is completely flexible. It's agnostic in terms of what you're actually doing within your DAG, so you can define these in whatever way makes sense for your use case. One level deeper, within DAGs, you have operators. So operators are like the building blocks of Airflow, and you can think of them as kind of like a wrapper around each task that's going to define what that task actually does. There are a couple of different main types of operators we generally refer to here that are listed at the bottom of this slide. So action operators, think of as execute a thing or a piece of code or something like that. So like Python operator will run a Python function, bash operator will run a bash script, things like that. You have transfer operators, which are sort of more specialized, designed to move data from one place to another. So that might be like the S3 to Snowflake operator, things like that. We'll talk more about those specialized operators as I go through. And then finally, you have sensor operators, or frequently referred to as just sensors. These are operators that are designed to wait for something to happen. So they're a way of building in more kind of event-based triggering into your DAGs. So there are sensors that wait for a file to land on S3, or wait for another DAG to finish running, or things like that. So those are kind of the tools that are in your toolbox as far as operators go. Again, one level down. So operators are the building blocks. They're a wrapper around each task. You can think of then your task is like the instance of an operator. And then you have your task instance, which represents a specific run of a task. So for a DAG and a task within that DAG for a point in time. So that'll make a little more sense when I show it visually in the UI, but just know that task instance is something you will hear a lot. You might also hear it referred to as TI, especially in code. So that's what that's talking about. And then kind of putting that all together, what that looks like visually is, again, within a DAG, you have your tasks. Each task is going to be defined by an operator, and then you can set any dependencies in between them. The next kind of core concept, building on that, pulling in the things I've talked about before, is like the Airflow ecosystem and how the community is really vibrant. Something that's resulted in is what we call Airflow providers. So these are Python packages that contain all of the relevant Airflow modules for interacting with some external service. So again, Airflow is designed to be an agnostic sort of orchestrator. You can do your work within Airflow, but likely you will be using other tools. Maybe that's something like AWS tools or Snowflake or Databricks or things like that. Because the Airflow community is really vibrant, most of these tools already have modules built for you to interact with them. So that will look like those operators that I talked about, or sensors, things like that. Those are separate to the core of Airflow. So those provider packages are maintained by themselves. You install them separately. So I'll show kind of how that works as we go through. But that's something to note. You'll hear providers a lot as well. And we'll talk about kind of how to go about learning more about each of those. And then just to show kind of how all of that fits together in a more real world implementation, you can imagine that you might have something like this, where you have a pretty complicated pipeline with lots of external services, S3, Databricks, Snowflake, Slack, Tableau, all of those things. Airflow makes putting together a pipeline like this and then orchestrating it really easy. So by using those, already built out operators and provider packages that are built specifically to do these types of things, you can define a pipeline like this without much code. And then you have with Airflow a one-stop shop to, again, manage and monitor all of this kind of data movement. So that's one of the really cool things about Airflow, again, is its flexibility. It's built to interact with all of these other services. So something like that is easy to implement. Okay, so with all of that in mind, I'm going to, again, move into talking about a demo and sort of show some of this in action. And actually, before I hop into the demo, I mentioned at the beginning that I want to talk a little bit about resources. And I think this will be relevant because I'm going to use some of these resources for constructing this demo. So these are great things that Astronomer has put out into the community that are available to everybody, and they're really great places to get started. If you're new to Airflow and you're looking to either implement a specific use case or learn about kind of a specific Airflow feature, there are lots of resources already out there. Again, because Airflow has such a vibrant community, you're probably not the first one to try and do whatever you're doing. So definitely use those resources. It's going to save you a lot of time. One I want to point out to folks is our Airflow guide site. So this is going to have guides on how to do everything from get started with Airflow. So I can look for basics. We have, things on just like what is an operator, things like that, to operators 101, there we go, to, implementing more specific use cases. So that's a great resource for everybody. We'll send that out after. The next one I want to point out is the Astronomer registry. So this is really relevant for those provider packages we talked about. The registry is going to be a great discoverability hub for what is out there in terms of integrations with Airflow. So any provider packages that are out there as part of the community are going to be here. They are fully documented. You can come and browse kind of available modules. So if I'm working with AWS and I want to see, what operators do I have available to me, what sensors, things like that. I can come here, I can see them, I can get, information on how to use them. I can also, one of the great features on the registry is this example DAGs. So these are going to be, DAGs that are already built out that will show you the actual code needed for using a specific operator, hook, sensor, things like that. Some of them are really basic like this one. So they're designed to give you a sense of how to use a particular module. Some of them are more use case driven. So to give you a sense of how to, put different pieces together in terms of the building blocks. It's relatively unlikely you'll find one that's exactly what you need for your specific use case, because obviously those vary widely, but these are really great for, giving you a starting point. And so you don't have to write all the code from scratch yourself. I use these all the time when I'm developing examples, because it takes a lot of time to just like remember what the import paths are and all of that stuff when you're writing the code. So it's much easier to just come here, find a DAG that has, pieces of what you need, copy this code, and then go ahead and, update that DAG as needed and work through it. So just as an example, I am going to grab one and show what that looks like. So I'm going to, let's see, come look at we'll do this ELT one from Salesforce to Snowflake. Again, this has a lot of information about what's needed with this DAG, as well as the DAG code. So I'll keep that kind of in my back pocket. I'll come back here in a minute. But from there, if I think this is kind of what I want to work with, let's go ahead and talk about running Airflow and getting started with it and what it actually looks like to build one of those DAGs. So with that, I'm going to hop briefly over to my terminal. So again, actually running Airflow is going to be highly specific to your, infrastructure and your use case and how you're working, whether it's just you working on it or whether you're working on this within your company. How you implement that in production, again, varies widely, but probably the easiest way to just get started with Airflow, if you're just learning, you want to play around with it, is to use Astronomer's CLI. Again, there's multiple ways you can do this as well. You can work just with the open source Airflow project, but the CLI is a little more straightforward. So our CLI called Astro, it is open source, so it's available for everybody to use. Again, one of the pieces of functionality within that is super quick getting started to run Airflow locally. You do have to have either Docker or some other container based software installed to use it. I think we also support Garage, throw that in the chat, whatever it is, keep me honest. I know we typically use Docker, but some folks might not. So once I have the Astronomer CLI installed, the flow that I can go through to get Airflow up and running locally to play around with it is initialize an Astronomer project. The command for that is astrodev init. I've already run that in this directory. What that's going to do is give me a set of files and folders to run Airflow in a Dockerized setup. So from there, I can actually get Airflow up and running by just doing astrodev start. I have already run that, obviously, in this directory. You can see, in my case, it used Docker Compose under the hood. It spun me up a couple of containers to run Airflow locally. If I do a Docker PS, you can see I've got 3 containers running. Remember, I mentioned that there were 3 main Airflow components needed to run Airflow: the web server, the scheduler, your metastore. Those are corresponding in this case to the 3 containers that I have running. So you can see I have my scheduler and web server, and then my Postgres database. If I hop back to my browser here and go to my local host, E80, you can see I now have Airflow running. So super easy to get started. Again, you can go download our CLI and start playing around with this today. But this will show me the basic Airflow UI. First couple of things I'll point out here in the UI before I dive into kind of the DAG code itself and building a DAG. Home screen here is going to show me a list of all of the DAGs that I have in this environment. Each of these is going to correspond to a single Python file. So we'll show what those look like on the back end in just a minute. But that's kind of the best way to define your DAGs. So best practice. So I have each one of these as a separate DAG or a separate pipeline. You can see some basic information about them. Obviously, some of these have not run before, so there's no status. A couple of them have. I can see successes. This one's got a couple of failures as well. You'll also notice I have this DAG import errors at the top. This is telling me that I have some sort of issue in one of my DAG files and Airflow can't import it. So I've got a Python file with the DAG defined, but it's not showing up in this list. If that's the case, you should get this import errors. You can click on this and actually see what the error is. So this is a great initial check of, is everything in my DAG at least defined in an acceptable way for Airflow? Is to look here. If you don't see any import errors, you should see all of your DAGs in this list. Cool. And then for an example of a DAG here, the first one I'm going to look at is this COVID data S3 to Snowflake as an example. When I click into this DAG, it's going to show me, I'm going to default to a tree view, which gives me some sense of the structure of my DAG, as well as an overview of a bunch of recent runs. So each of these little squares here represents a task instance. Remember I talked about that, a task at a point in time. So each column here is a DAG run. Each square represents kind of what happened in that task. You can see I have a mix of colors. So obviously the green ones are successes, so everything was good. In this case, I have a couple of failures, my tasks, and you can see that the orange ones are tasks that were skipped because I said they were downstream. So they needed to have an upstream task finish and it didn't, it failed. So they weren't run. Tree view is a really great way of kind of seeing what's going on initially within your DAG. You can click on any of these task instances, especially the failure if I want to figure out what's going on. You can click on the log button here. This is going to show me all the logs for the task. This is true of the successful ones too, but especially for the failure, you know, I can come in here and kind of figure out what the error is so I can go about troubleshooting that. Other really important view kind of within the UI here is your graph view. This is obviously going to show me a graphical view of what's going on in the DAG, super helpful for getting a visual sense of what's going on. So you can see in this case, I have some parallel tasks that are generating files. Those are this Python operator, it's light pink color. I'm then using one of those transfer operators, S3 to Snowflake. So basically what's happening here is I'm grabbing data from an API. I'm sticking it in S3, and then I'm uploading that S3 file to Snowflake. And then if all of those are successful, I'm going to use the Snowflake operator, again, another specific operator, to run a Snowflake query. In this case, it's calling some stored procedure to do some transformations on the data. So let's look at kind of what this DAG actually looks like in code, what it takes to define something like this. I will note that the code tab here is going to show you the code for this DAG. So that can be a super useful way, especially if you don't necessarily have access to the underlying code for your Airflow environment, or if you want to make sure that what Airflow thinks the code is actually what the Airflow code is. This can be a great place to look. You can't actually update the code here. So for that, I'm going to hop back into my code editor here. Remember, I initialized this project in my terminal, so that's the directory I'm working out of. That's what I'm pointed to here in this code editor. Remember when I said using the Astronomer CLI initializing a project, it's going to create this file structure for me. So kind of the important pieces of this, again, this is all Docker based. So I have a Docker file that's going to pull my Airflow image. You can change this if you want to work with like a different version of Airflow or something like that. Other pieces of this that are important. So your DAGs folder, again, is where all of your DAGs are going to go. You can see I have a bunch of Python files here, including this COVID to Snowflake. This is the DAG we were just looking at. In general, this list of DAGs here will correspond with that list of DAGs that you saw in the UI, minus whichever one of them has an import error and some issue going on. So again, best practice is to define, one DAG per Python file, at least if they're static, and keep them clean in that way. So we'll go through this COVID to Snowflake DAG as an example. And first thing you'll see in the code here is all of my import statements at the top. So I have to import, my DAG function and things like that from Airflow. I also have to import all of my operators that I'm going to use within this DAG. You'll notice that some of them have these provider import paths. So for the Snowflake, and remember, I'm uploading data to S3, so I'm using the Amazon provider for that. Again, those providers are separate from the Airflow, the core of Airflow. So they're just Python packages that you can install from PyPy. In the case of an astronomer project, the way we recommend doing that is adding them to your requirements.txt file. This will be automatically created if you use the CLI. If we hop over here, you can see where I've added a couple of them, including the Snowflake one that I'm using in this particular DAG. So just note that if you are going to use a provider package, you have to make sure it's installed in your environment. Otherwise, you'll get an error there. Moving on down the DAG. So I do have this upload to S3 Python function. So in this particular case, there's not an operator that does exactly what I want this function to do. So taking data from, grabbing it from an API and saving it to a CSV on S3. So I've written a function to do it myself. You can see I use that S3 hook to make that connection. Then I'm just doing some basic Python to, grab that data and then load it into S3. That function will then be called down below with my Python operator. So Python operator can be used to execute any, custom Python function that you define. I have some kind of default arguments that I'm passing into my DAG that are defined here. So I'll talk more about these in a moment. And then again, some additional information that I'm using kind of within the stack. So I'll come back to these as I get to them in the operators. Here I instantiate my DAG. So this is really important. This is required for Airflow to recognize your Python file as a DAG, is to instantiate it using that Airflow DAG function. You have to give it a name. So that's my COVID data S3 to Snowflake. You should define a start date and make it a static one. If you don't have a start date in your DAG and you try and run it, you can get weird behavior. So have a start date here. I can define any other kind of metadata I want about this DAG. So I won't go through all of this in detail. There are a ton of different options in terms of how you can configure these. You have lots of flexibility over when your DAG runs and what happens and how your tasks dependencies are defined and how you can control, concurrency within your Airflow environment and things like that. Those are all sort of more advanced topics, but just note that most of that stuff can be passed in here. One important piece of this is your schedule interval. So that's going to define when your DAG gets scheduled. You don't have to have one. So you can have a DAG that is just triggered on an ad hoc basis. That's totally fine. You can set this equal to none, like the Python none, and then it will just be run whenever you trigger it. One other important parameter to pay attention to is catch-up, mostly because catch-up actually defaults to true. So if you don't overwrite that, when you turn your DAG on, it will try to catch up any runs from whenever your start date is. So if you have a start date like this, that's, a year and a half ago, and you're running daily and you have catch up equals true and you turn this thing on, it's going to try and trigger, however many 500 DAG runs, which is probably not, maybe it is what you want, but in a lot of cases, maybe not. You have to be aware of your infrastructure. So be careful about that. Kind of best practice in my book is to just default to or always put catch-up equals false in your DAG unless you intentionally want it to do otherwise. From there, within this DAG context, I can go ahead and define all of my operators. So I have kind of a dummy operator just to show, a start. I'm actually going to skip over the snowflake operator for a moment. And then this is where I'm creating those parallel Python operators and snowflake operators. You'll notice, or S3 to snowflake operators. You'll notice that I'm actually doing this in a for loop. So I'm looping over a set of endpoints. These are different states that I'm pulling data for. So this is to show that, again, because everything's defined in Python, you can get dynamic here. So this is dynamically generating these tasks. I could, change something. If I no longer care about Utah, I can go ahead and, change that and save that, and I'll see this change kind of in my DAG and the tasks. So you can, again, do things dynamically in that way, but that's why within this loop, I'm generating a Python operator for each one. That's calling my upload to S3 Python function that I defined above. And then I have my S3 to snowflake operator that's doing that transfer. You'll notice that within these operators, the parameters are different. Obviously, it makes sense. This one's just executing a Python function. This one's doing a fairly specific data transfer that's relying on 2 external systems. This is one place where the registry is a really great resource for you to learn about. If you, find an operator that does whatever your use case is, and you want to know, like, what are the parameters that I put in? What do I have to provide to Airflow? What should go in them? The registry is a great place for that, especially with those example DAGs. Because again, this will vary based on every operator. The one thing that doesn't vary is they all have to have a task ID with a unique name there. So if you have duplicate task IDs, I think Airflow will throw an error. One thing to note on your DAG ID, if you have duplicate DAG IDs within your environment, you will not get an error. Airflow will parse whichever, or it will show in the UI whichever DAG it happens to parse first. So that can be a frequent point of confusion. If you're wondering why your DAG isn't showing up, especially if you copied it from somewhere else, or like from the example DAG, make sure that you give it a unique name. So, and then finally within this, I define my task dependencies. So you have a couple of different options in terms of defining dependencies. These bit shift operators are one of them. Those are my personal preference. There are also others that are detailed in the Airflow documentation. And again, this can get obviously much more complicated. In this case, it's a pretty simple progression. But as long as you have no loops, whatever you need to set in terms of dependencies will work just fine there. So if I hop back to my DAG here, just to show I did make that change. So again, I took a task away here, or I should say 2 tasks, one of those loop endpoints. So you can see I now have just 3 parallel tasks here. The other thing I want to note about this DAG, I'll look at the code here this time, is within both my function that uses the S3 hook and my snowflake functions, I have what's called a connection ID. So in this case, the parameter is AWS con ID. With Snowflake, it's Snowflake con ID. So you can see that here in the Snowflake operator and here in the S3 to Snowflake operator. Those are the connections that are going to allow Airflow to talk to those external systems. So usually that's going to require some sort of credential. You definitely don't want to put those credentials like in plain text in your environment. So Airflow has a couple of different options for managing those. The most simple, if you're just getting started, is to use the built-in connections module. So you can see I'm referring to string for the name of the connections in these cases. If I go to the admin tab here in the UI, there's this connections option. And you can see I have a couple defined here. So like for my Astro S3 workshop, if I look at this, this is the connection to S3 I'm using. I have a login. There is a password here. It's obfuscated for security reasons in the UI. Also, if you have anything printed out in the logs regarding these connections and stuff, Airflow will take care of not printing out your password in plain text. So that's one, more secure way to handle credentials there. Each one will look sort of different in terms of how you have to define it. Obviously, Snowflake, I have different stuff in here, including like a schema, my login, host, things like that. So those will vary. Registry is a great place to learn more about those as well. Airflow documentation has a lot of great resources too. But that's probably your best place to get started. But again, just note that if you want Airflow to talk to your systems, you will likely need to define those. Cool. So I will pause there. That was a lot of information that I just ran through. We have about 15 minutes left. I want to leave it open for some Q&A. Oh, actually, sorry. Before I do that, I have to pop back to my slide. I have one more slide, and then I'll open it up to Q&A. As we sort of gone through this in our demo, I just wanted to circle back again to those best practices. That was something we promised to give you some tips for getting started, help you like get the most of Airflow. This is kind of reiterating a lot of the stuff that I've already gone through, but it's just going to help you with your Airflow experience. Again, because everything's just defined in Python code, you can kind of do whatever you want in Airflow for the most part, but there are some things that you should do, again, to make that experience better. Things I've already talked about are, again, use providers. So those are out there for you. They've already been built by the community. Don't reinvent the wheel and just write your own Python operators unless you need to. Obviously, in some cases, that's required. But do use those provider packages. Use connections. So don't put sensitive information directly in your DAG file. Keep your DAG files clean. So define one DAG per Python file. You can also, import Python functions or SQL scripts or things like that from other files so that you can keep your DAG file pretty clean. I didn't talk about this very much, but use templated fields. So Airflow can do all sorts of things with variables and macros so that your DAG can be updated, at runtime. And so that you don't have to hard code, information into your DAG file. So that's something, there are lots of resources out there for. And then again, with Airflow, remember that, this is, basic data pipeline. So use data engineering best practices as well. So design idempotent DAGs so that they produce the same result no matter how many times you run them. And keep your tasks atomic. The DAG that I showed was a good example of this. You could obviously write a single Python function that did all of that work in one go, but it's really hard to figure out what's going wrong if you have any failures and recover from them. So try and keep each task doing a single unit of work kind of when you define these. Okay, so now I'm going to open up to Q&A, but I do want to also note that a great next step is to get Airflow certified. So that could be a great way to learn Airflow and also get something that works or is, a good resume booster. We are offering for attendees of the webinar a discount code for our certification courses. Mark Lamberti develops all of those. If you've done any, if you've looked into Airflow at all, you're probably familiar with him. He's all over the place. Flow Celebrity, he does really, really good trainings. So going through his course is a great way to get started with Airflow. So you can use that code discount there. So with that, I will stop talking for a moment and pause for answering any questions. Sorry, I'm gonna go. I'm assuming, oops, assuming Viraj is still having audio issues. So I am going to pull up the Q&A here. Second. Okay. So this is a really great question around using Airflow for ETL or ELT. So the question is, Is it common to do the transformation element of this directly in Airflow using something like SQL? Or is it more common to use kind of specialist like ELT tools like dbt, Snowflake is another one, kind of things like that? That's a great question. The answer is you can do either. It definitely depends on your use case. So, you know, offloading that transformation to a tool that's highly specialized for that, like a dbt or a Snowflake or something like that, is oftentimes a really good route for folks, especially if you know, are dealing with really large data sets. And you need something that's kind of functionally very specific to the use case. Airflow is a really good tool to fit into that, again, because of those provider packages. So you can still orchestrate everything from Airflow, but you can offload that work to those other tools. dbt is one where there will very shortly, I think, be a specific dbt provider. Using dbt and Airflow is really common. That said, you can also do that within Airflow. So obviously that's going to, you know, depend on kind of what your data looks like and what your Airflow infrastructure looks like, how much you can support that. But if your data is more suited to doing the transformations like just in Python or in SQL, you can absolutely do so. The Astro library is one thing that our last webinar was on for doing exactly that. So we can maybe Raj can grab the link to that and throw it in the chat. That would be a good place to get started there. Good question. Okay. Just going through the Q&A here. It's like, so we will be sending out a recording to the webinar for anybody who came late. No worries about that. You'll have all of the resources available to you as well.
Awesome.
Yeah.
Okay,
oh,
go ahead.
Sorry, I was going to say, whoever asked about is the certification course the same as the one Mark did on Udemy? It is not the same. It is a bit more in depth and sort of tailored towards helping you pass the certification. So it goes into a bit more topics than his Udemy course. It is still, I took Mark's Udemy course a long time ago when I was started with Airflow. So it's the same sort of great instruction and great resource there. But a little more fully fledged in that way. So. Sorry, Barrage, you were going to say something.
No, you're good. I think one question that came up before that I think I tried to answer, but probably good if you answered it too, is for the content that you showed, do you have to be an astronomer customer to use it, or does it work with open source Airflow as well?
No, everything I showed today works with open source Airflow. In fact, the only part of it that is specific to, well, actually, I shouldn't say that. I did show using the CLI to run Airflow locally. So a lot of our CLI functionality is for interacting with the Astronomer platform for customers. But to just run Airflow locally, like you saw me doing, that's totally available to everybody, and the CLI is open source. And the rest of the stuff that I showed in Airflow is all open source, available to everybody.
Awesome. I think that was it for questions.
Cool. We have a question on how, Raj, do you know, does the certification have an expiration?
Not that I know. Not that I know. I believe it should work for a while.
Okay. Somebody asked about sort of what benefit Astronomer brings on top of Airflow. So Astronomer is going to help with running and operationalizing Airflow. So all of the functionality that I talked about today in terms of the DAG authoring perspective will be the same, but Obviously, running locally on your computer, like you saw me doing, doesn't work for most people in production. So then the question becomes kind of how do you actually take Airflow and run it in production in a way that's scalable and reliable. So that's the piece that Astronomer helps with. We're more than happy to chat with you more about that. So definitely feel free to reach out to us and we can provide more details there.
Awesome. Kenton, this was great. Thanks so much for going through everything.
Yeah, absolutely.
There are a couple more questions here. I think you're seeing the same ones in the group chat, and I believe we've answered some of them. Cloud offering, that one's answered. Is any part of the certification course live? Correct me if I'm wrong, but I believe that's something we do for our customers, but not as part of our video certification.
That's correct. So the certification course is all pre-recorded, but you can go through at your own pace. Or I should say it's designed so that you can go through at your own pace. It is not live. Yeah.
Awesome. Alrighty. So I think after that, we are good on questions. I don't see any new ones coming through. For more in-depth webinars, it's a good way to end. Stay tuned to your email. We'll have a few more in-depth ones coming later in the next couple of months here. Kenton, I know we've talked about some topics, but I think at least the ones we have planned in February all look pretty good.
Yeah, I'm excited. Lots of great content coming up, both kind of existing Airflow features, diving into those more, as well as some new stuff that's coming out that we're excited about.
Eric beat me to posting the link to the old ones as well, so please check those out.
Awesome. Thanks, Eric.
Yeah. Alrighty, everyone. If that's all, thank you so much for your time today, and we will see you in 2 weeks.
So, thanks, everybody.